Hello and welcome to lesson 4.1, equivalent trigonometric functions. So these six formulas that you see here are used to expand if you have angles A and B. So sine of A plus B, sine of A minus B, so cosine of A plus B, cosine of A minus B, and so forth. Now how these are actually written depends on what you're going to use. So if you're going to do cosine of A plus B, you're going to follow by solving cosine of A times cosine of B, and because that one was on the top, you're going to use the minus sign, sine of A, sine of B. So for example, for calculating cosine of pi minus pi over 3, to find another equivalent expression to it, cosine of pi times cosine of pi over 3 plus sine of pi times sine of pi over 3. Now, you are hoping, or we are hoping that you will actually memorize these formulas right here. It's not necessary to actually memorize all of them. I'd say memorize the first two, and you can figure out the third one just by realizing sine divided by cosine is tangent. These next three formulas are called double angle identities. The double angle formulas or identities are used to actually calculate it if the two angles were actually exactly the same. Now, this second one can be actually changed due to the fact that sine squared theta plus cosine squared theta is equal to 1. Due to this fact, you can rearrange this sine squared theta or cosine squared theta onto the left side or the right side of the expression and rearrange it so that cosine 2 theta instead could be equal to 2 cosine squared theta minus 1, or cosine 2 theta could also be, in terms of just sine, 1 minus 2 sine squared theta. Now again, I'd suggest you memorize at least the first two. You can always figure out the last one just by taking one and dividing by the other one, and using some trigonometric identities that you need. So let's see how this is useful in calculating some values. So in our last unit, we solved finding exact values of expressions in terms of multiples of pi over 4, pi over 6, or pi over 3, or even pi over 2. Well, now this is not actually a multiple of any of those, but it is a combination of them. So for instance, 5 pi over 12 can be written as 3 pi over 12 plus 2 pi over 12, which can in turn be reduced to pi over 4 and pi over 6. Well then, what we can do is we can use our special triangles that we were given from before, or we knew. Use these to actually figure out this expression. So first of all, sine pi over 4 plus pi over 6, referring back to that sine addition angle formula, is equal to sine pi over 4 times cosine of pi over 6 plus cosine of pi over 4 times sine of pi over 6. Using this, we can substitute our expressions We can multiply and simplify. Now you can leave it in this format, or what you can do is you can multiply the top and the bottom by square root of 2 in order to get rid of the square root of 2 in the denominator. So that could give you square root of 6 plus square root of 2 all over 4 as an alternate expression. We can also use these formulas to actually help us simplify some expressions. So for instance, sine of pi over 2 plus theta. Well, again, we can use our addition angle formula to separate this into sine of pi over 2 times cosine theta plus cosine of pi over 2 times sine theta. Now, because we don't have actual values for cosine theta and sine theta, we can't change those. But we do have values for sine of pi over 2. Sine of pi over 2 is just equal to 1. Cosine of pi over 2 is just the value 0. So this can simplify this expression into cosine theta. So sine of pi over 2 plus theta is equivalent to cosine theta. You can even use this in order to solve problems when given just specific trigonometric ratios. So here we're given sine of A is equal to 3 over 5 and tan B is equal to negative 5 over 12 in the domains where A is between pi over 2 and pi, and B is in between 3 pi over 2 and 2 pi. So I'm going to draw a sketch of what I'm talking about here. So first of all, our angle A would look something like this. And I know sine of A is 3 over 5. In other words, my opposite is 3 and my hypotenuse is 5. Using Pythagorean theorem, I can find out this other length. Realizing it's a negative, I can work it out. I can do the same thing for the angle B. Please realize these triangles are not drawn to scale, so don't worry about that. It's just they're in the correct quadrants. And remember that the hypotenuse cannot equal a negative value. So now that I have this expression right here, or these two triangles drawn, I can actually work out cosine of A plus B. And I can actually find it out exactly. Another option is to actually solve for A, solve for B, add the results, and figure out the cosine value of it. But that might give you an inaccurate value. So cosine of A plus B is equivalent to cosine A times cosine B minus sine of A times sine of B. Okay, so with this information given, cosine of A is adjacent over hypotenuse, which is our negative 4 over 5. Cosine of B turns out to be 12 over 13. Sine of A we already had was 3 over 5. Sine of B turns out to be negative 5 over 13. So now it's just a matter of solving this. And get an exact value of negative 33 over 65. Whereas if we actually solve for a and b, we would get approximations and not an exact answer like such. Okay, how else can we use this? Well, these ones look like they're the double angle formulas. This one looks as if this looks like cosine 2 theta, where theta is equal to 3a. So this can be simplified into cosine of 2 times 3a, which is equal to cosine of 6a. The second function looks as if theta is equal to 4a for the tangent function. So this would be tan of 2 times 4a, or tan of 8a as another option. Okay, so let's try this again. This time we're using double angle formulas given this information. So sine theta is equal to 2 over 5. It's in our second quadrant because theta is between pi over 2 and pi. Using Pythagorean theorem, again, I could figure out this value. Turns out to be square root of negative 21. Oh, sorry, negative square root of 21. And again, we could figure out what our values for sine of 2 theta is and cosine of 2 theta. So sine 2 theta is equal to 2 sine theta times cosine theta. Oh, sine theta was already given by 2 over 5. Cosine theta is negative square root 21 over 5. So this is negative 4 times root 21 all over 25. To work out cosine 2 theta using exact values again, we have an expression of cosine theta squared minus sine squared theta. Well, cosine theta, again, was negative square root 21 over 5. But we're squaring that value. And sine theta was 2 over 5, but we're squaring that value. This works out to be 17 over 25. And thus concludes this lesson.